Hello everyone. Today we are going to discuss the topic about duplicate document detection using Minhash algorithm. Think about search engines like Google. They index billions of web pages every single day. But here's the problem. Like many many of these pages are duplicates or near duplicates. This leads to wasted storage, slower search performance, and repetitive search results. So, detecting and removing search documents become crucial to keep search systems fast and clean. Now, let's understand the difference first. Duplicate document is an exact copy, for example, same PDF uploaded on two different websites. And a near duplicate, on the other hand, is almost identical, but the minor changes like two new articles about the same event written in slightly different words. Detecting exact duplicate is easy, but near duplicates are the real challenge because the text is not identical, only similar in meaning. So, traditionally, we have two main techniques. These two main techniques are used. One is shingling and the other one is Jacquard similarity. Shingling means splitting a document into small group of words called k-grams. For example, I love machine learning with given k is equals to 2. It means I love and love machine and machine learning. Then we use Jacquard similarity, which measures how many shingles overlap between two documents. If it's one, then they are identical. If it's zero, then it's completely different. But this process becomes very slow and memory heavy when we deal with millions of documents. And that's where Minhash comes in, the small shortcut. Instead of comparing the entire documents, Minhash creates a short signature for each one. These signatures are built using multiple hash functions, and the fraction of matching hashes tells us how similar two documents are. So we are comparing small signature vectors instead of full documents, saving time, memory, and computation. So let us see here stepwise through how Minhash actually works. Step one is pre-processing. First, we clean the entire text, convert it into lowercase, and remove punctuations, numbers, and stop words like the or is. Then we create shingles. For example, data mining is fun becomes data mining is and mining is fun. Here the K is 3. Now the step 2. Creating the shingle universe. We collect all unique shingles from every document. This becomes our universal set. Then each document is represented as a binary vector. If it's 1, that means shingle is present. If it's 0, then the shingle is not present. This forms a large document, shingle matrix that represents all documents. Coming to step 3. Here, applying hash functions. We use multiple hash functions like a into x plus b into I mod c. Each one gives a random permutation of shingles, helping us capture different structures in the document. Step 4. Generating min-hash signatures. For every document and hash function, we calculate hash values for all its strings. Then we pick the minimum value, hence the name minhash. The minimum value becomes that document's signature entry. Repeating this with many hash functions gives us short signature vector for each document. Finally, we compare these signature vectors instead of full documents. The formula is simple. Similarity equals to number of matching hash values by total hash functions. It means K. If the similarity score is above a threshold, let's say zero point 0.8, we mark them as near duplicates. And that's it. So it is a super fast, memory efficient, and scalable for millions of documents. Let's take a quick example. Document 1, it's saying data mining is interesting. Document 2 is saying data mining is very interesting. When we generate three-word shingle, D1 gives data mining is and mining is interesting. It gives two shingles, but D2 gives us three shingles. Data mining is very, and is very interesting. It gives us three shingles. So two out of three shingles match. So similarity is 2 by 3, about 66%. That means two are near duplicates, one is exact copies. I mean, not exact copies. The main hash algorithm has several advantages, like it's very fast, efficient, works on large data sets, and handles both exact and near duplicates. It also reduces dimensionality, meaning we only store small signature instead of huge text files. But there are few limitations too. The accuracy depends on the chosen hash function. It doesn't understand semantic meaning. And sometimes it may give false positives or negatives. Still, Minhash remains powerful and widely used approach in search engines, plagiarism checkers, and social media platforms, helping us maintain clean and duplicate free data. And that's about the main hash, a small algorithm making a big difference in information retrieval. Thank you for listening.